download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about ionic bonding. Now an ionic bond is the transfer of electrons. Okay, so it is the giving and the receiving of electrons. Now you'll remember from last video that group 1 element loses an electron, whereas a group 7 element gains an electron. So if a group 1 element loses an electron, they become a positive ion. And if you don't know what we mean by an ion, and you don't know how to draw these, then please watch the previous video on drawing ions. And if a group 7 element gains an electron, it will become a negative ion. Okay, so here we have a positive ion and a negative ion. These oppositely charged ions are now strongly attracted to each other. Okay, they are attracted to each other by something called an electrostatic force. Okay, and that is because they are oppositely charged. A positive and a negative attract, so they bond. Okay, so the positive ion and a negative ion bond together because they are now oppositely charged. They are attracted to each other by an electrostatic force. This bond here is called an ionic bond. Okay, and it is called so because there has been a loss of an electron and there has been a gain of an electron. There has been a transfer of electrons, causing a positive and a negative ion to be attracted to each other. Now we can draw dot and cross diagrams to show ionic bonding. Okay, and I'm going to teach you and talk you through a couple of examples of how to do that now. So the first question here, draw the dot and cross diagram to show how potassium reacts with fluorine to form potassium fluoride. Okay, now one bit of advice, especially when you're starting off doing dot and cross diagrams, is to draw the electronic configurations for both of the atoms that you've got first. This is what I would suggest when you're starting off. Okay, so if we were to draw the electronic configuration for potassium, okay, so we find potassium on the periodic table, it's got 19 electrons. So we do, we do 2 in the first shell, sorry. And if you don't know how to draw electronic configurations, then please watch my previous video on electronic configurations to show you how to do this. Then we'd have 8 on the next shell, and that would make 10. We'd have a further 8. And then we'd have one more shell with 1 on. Now we can check we're right, of course, because potassium is in group 1, therefore it should have 1 electron in the outer shell. Now we can draw the electronic configuration for fluorine. We find fluorine on the periodic table, it's got 9 electrons. Okay, now what I would suggest you do here is we've noticed we've drawn the first electron with dots, and now what we're going to do is we're going to draw the second atom, or the second element, with crosses. Okay, now that is important when we're showing the transfer of electrons, so we can see which electrons have come from where. Okay, now it doesn't matter which way you do the dots, which way you do the crosses, as long as you do 1 as dots and 1 as crosses. So, fluorine, 9 electrons, it's going to have 2 in the outer shell. See, notice there I've done cross. And then it's going to have 7 left, so the next one is going to have 7. Okay, so we've got our 2 electronic configurations for potassium and for fluorine. Okay, now what's going to happen here when they react is that this electron in the outer shell of potassium, remember potassium wants to lose this and fluorine wants to gain one to get a full outer shell, the potassium is going to give this electron to our fluorine. Okay, it's going to give the electron to fluorine. So now what we need to do is to draw our ions. Okay, we need to draw our ions to show what would happen in this particular reaction. Now we drew ions in the previous video, so if you don't know what I'm doing here, then please go back and watch that video of me drawing ions. Okay, but if potassium has lost 1 electron, we now only have to draw the outer shell here. Okay, so there's now 8 electrons in that outer shell there because it's losing this electron here, so it doesn't have this outer shell anymore. So we draw the 8 electrons here, and again draw them as dots. Okay, now it has lost 1 electron, and therefore it's going to be a +1 charge, or a plus charge. And now we're going to do your fluorine. It's going to gain that electron. So if we draw the outer shell of fluorine, it's got 7 electrons in its outer shell. Notice I'm drawing these as a cross to show that they're different. And then that 1 electron that's come from potassium is also going to be represented as a dot because it's come from potassium. We draw that there to show that that's a different electron to what it had. It's now become a minus. And that's how we show an ionic bond between the two. Remember from the previous part that these are now attracted to each other because they're oppositely charged, and that is an ionic bond. Okay, these are now ionically bonded, and that's how we represent them with a dot and cross diagram. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. So let's do another one. So draw the dot and cross diagram to show how magnesium reacts with oxygen to form magnesium oxide. Well, we look on the periodic table, magnesium has 12 electrons. So let's draw that out now. First shell 2, then we're going to go to the next shell which has 8, and then we're going to go to the final shell which has 2. We can check we're right, magnesium is in group 2, so it should have 2 electrons in the outer shell. Then we find oxygen. Well, oxygen has 8 electrons, so we draw that out now. Now remember, this time we'll represent them as a cross. So 2, it should have 6 left. So 1, 2, 3, 4, 5 and 6, and that is oxygen. Now when these ionically bond, magnesium is going to give these 2 electrons in the outer shell to oxygen. So what we're going to do is we're going to first draw magnesium as an ion. So we're just going to draw its outer shell. So it's lost these 2, so therefore the next outer shell is going to have 8, 7 and 8. Because it's lost 2 electrons, it's now got a 2 plus charge. And oxygen is going to gain those 2 electrons. So we draw the original outer shell of oxygen, which had 6 electrons in, so 1, 2, 3, 4, 5 and 6. And then we're going to draw the 2 electrons that we've received from magnesium, 1 and 2. And then because it's gained 2 electrons, it would be a 2 minus charge. And that they would now ionically bond because they're attracted to each other from the electrostatic force because they're oppositely charged. Now it's not just as simple as one atom of something bonding with one atom of something else to make something. So for example, think water, H2O, that needs 2 hydrogens for 1 oxygen, okay? And it's the same here with magnesium chloride. So I'm going to show you how we represent this now. So the same steps apply. First of all, we're going to draw the electronic configurations for magnesium and chlorine. So magnesium has 12 electrons, therefore we're going to do 2, and then 1, 2, 3, 4, 5, 6, 7, 8, so that's 10 electrons, and then 2 in the outer shell. Magnesium is in group 2, therefore we know it should have 2 in the outer shell. And chlorine has 17 electrons, so we're going to draw chlorine, but remember this time we're going to represent it as a dot. So 2, 1, 2, 3, 4, 5, 6, 7, 8, and then 7 more, 1, 2, 3, 4, 5, 6 and 7. Now here we've got an issue because magnesium has 2 electrons to give and it needs to lose those 2 electrons, otherwise it won't want to react. But chlorine only needs 1. So that means we need another chlorine to take the second electron that's available. So let me just draw another chlorine. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17. So now that magnesium can give one of its electrons to this chlorine and it can give the other electron to this chlorine here. Okay, so that would be the cross there, and we'd then put a cross there. That means we need 2 chlorines to react with 1 magnesium. So the way we'd write this as a formula is Mg for magnesium, Cl2, because we need 2 chlorines to react with 1 magnesium. So how do we then represent these as our ionic bonds? Well, we can draw the ions for these, and if you don't know how to do this, then please watch the formation of ions previous video. So magnesium, we draw the next outer shell, so that has 8 electrons, it's now full. It has lost 2 electrons, okay, it lost 2 negative charges, therefore it's a 2+. And then we can draw the magnesium, which has 7 of its own electrons, and then each one has 1 from the magnesium, so that's gained 1 electron, so that would be 1-, but because of 2, we need to draw another one. 1, 2, 3, 4, 5, 6, 7. 1 electron from the magnesium, so 1-. And again, remember that these two will now bond. They'll be attracted to each other because of an electrostatic force, okay, causing them to attract, and therefore they will ionically bond. So what we'd now like you to do is have a go at answering these questions here and really starting to test your understanding. So pause the video now. Okay, let's go for the answer. So number 1, what is ionic bonding? Well, ionic bonding is about the transfer of electrons. Okay, which means obviously one atom is gaining an electron and another atom is losing an electron, or 2 or 3. Okay, so the transfer of electrons is ionic bonding. Now question 2, draw diagrams to show how electrons are transferred when. Okay, so what I've done is I've done these for you. So with lithium fluoride, you should have drawn this. Okay, so 2 electrons on the outer shell for lithium, and it's a plus charge. And now 8 electrons on the outer shell for fluorine, but remember one of those coming from lithium to become a negative charge. And then B, we've got potassium oxide. So what you should have drawn is there should be 2 potassiums to react with the 1 oxygen. Okay, and that's because potassium only has 1 electron to give, but oxygen needs 2. So the 2 potassiums both have full outer shells, they both have 8 electrons, and then a plus charge because they've lost 1 electron. And the oxygen has gained both of those electrons, so it's got 6 of its own electrons, then 2 electrons in dots to represent 1 coming from each potassium, and it's now for a 2- charge. Aluminium chloride, we need 3 chlorine per 1 aluminium. So we draw aluminium has lost 3 electrons and therefore it now has a full outer shell, but it's a +3 charge, or a 3+ charge. And then we draw the 3 chlorines, each receiving 1 electron each. So they have their 7 electrons and their 1 each that they gained from the aluminium, and they have each become a negative charge. And finally we've got sodium oxide, which we need 2 sodium, okay, because sodium only has 1 electron to lose, but oxygen needs 2. So we draw a full outer shell for sodium, which is 8 electrons, and it's lost 1, so it's a plus charge. The oxygen has gained both of those electrons from each of the sodiums, so we draw it with its 6 normal electrons and the 2 that's come from the sodium, and it's a 2- charge. So you've now there learnt about ionic bonding, what ionic bonding is, and then how to represent that with a dot and cross diagram. You can now test yourself using the quiz and answer any exam questions on the topic. If there's anything you need help with or anything you didn't understand, then please get into contact with one of our tutors who will be happy to help.